The challenge here is to build the fastest America's Cup boat for the competition in 2021 in Auckland. Here in Britain, we've never won the Cup, despite the fact it started here with a trophy that was made by the Royal Yacht Squadron. So we are still trying to win it back. The INEOS Team UK is the latest challenge to try and do that. Renishaw have given us access to a wide range of world-class engineering solutions, in particular additive manufacturing, where we had no resource available to us, and now we build a lot of material with them. We also use their encoder solutions to measure the boat's performance. We've used their resource on HMI, human-machine interface, to develop really ergonomic solutions for controlling the boat. And we've also used materials science resources as well, so spectroscopy and other research.
INEOS and America's Cup and the extreme challenges that they are facing means that their measurement requirements are much higher. So we've got a much better fit with the type of encoders that we do with the requirements for the boat. This boat is going at 50 knots. You don't need to move too much of a control surface before you have very significant effects happening. So it's very important to have that level of accuracy.
So AM works really well. It complements INEOS. Everything that they do is to design the best and the lightest yacht. So they're using advanced materials. So the vast majority of the boat is made up of carbon fibre composite. It's very high modulus, it's very strong, and it's a very good material for boat design. Occasionally though, there are instances where you need compressive loads to be transferred, you need bearing surfaces, and carbon composite can't compete against titanium in that respect. Titanium is one of the best materials in terms of strength to weight, but it's quite a hard material to manufacture, to forge or machine. So that's where additive comes in really, that we can build these components in titanium exactly in the shapes that are needed to transmit the loads.
It's a real joy to work with a team that have a real desire and passion to get things done, and it reflects on us as well. So we feel the same.
In the next 2 years, the guys are designing a second test race boat, and we will be more heavily involved in that. And our aim is to get as many additive components on there as is sensible. At the end of the day, it's a race won and lost on the water, but actually it's probably about a 4-year development cycle that makes the boat and makes the race. So you win the race at the draftsman's board, really.
I think the longer we worked with the team there, the more we realised the facilities and resources and the engineers that they had, and the other technologies, the new technologies that we could have available to us. So we've been able to deepen and to widen the relationship in the areas in which we've worked together, and that's really been fantastic for this edition of the Cup.
It's amazing when I look back when I started sailing 30 odd years ago, and how the sport has developed, and even 10 years ago, to think a scale of a monohull, 75-foot monohull, lifting up, foiling out of the water, going close to 60 miles an hour boat speed. You wouldn't really have dreamt that was possible. And it's hugely exciting to have been involved with the sport as it's going through this transition into foiling boats. I'm really excited about the future of the America's Cup. I love the technology behind the America's Cup, and that's where Renishaw really plays a huge part in our team. And we're incredibly lucky to have that support, frankly, and it's going to make a big difference to the success of the team.